Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! So if we imagine we've got the 25 metre pipe here, and we've got the 35 metre pipe here, the question's basically asking us what can we cut all these pipes into, and they all have to be the same length that will fit with the 25 metre and the 35 metre. And essentially what this question is asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1 and 25 and 5 and 5, and the factors of 35, which will be 1 and 35 and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 metre pipes. So 1, 2, 3, 4, not to scale, and then 7 of these, so 1, 2, 4, 5, 6, and so there's 7 in total. So each of these are 5 metre long, and there's no wastage, and that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 metres. So for this question we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this and like this. It could be the other way around, and it could be distorted, but it basically goes down to a point along here. It goes to infinity, and it goes to infinity along a point over here, and obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down, and this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down, but here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph, because it's a nice U shape. So if we carry this on, it could be a nice U shape. It could also be a cubic graph as well. So it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic function. So this question says that Adrian, Ben and Charlie have some sweets, and the ratio of Adrian to Ben to Charlie is 9 to 6 to 13. But it also says that Charlie got 56 more sweets than Adrian. So there's 56 more sweets. Well, looking at the actual parts of the ratio, there are 4 more parts. So plus 4 parts, which represent plus 56 sweets. So the 4 extra parts are worth 56 sweets. So 4 parts are worth 56 sweets. So 1 part would be 56 divided by 4, which is 14 sweets. So all we need to do now is work out how many parts there are. Well, there are 9 plus 6 plus 13 parts, which is 28. And each part is worth 14 sweets. So the total number of sweets will be 28 times 14. So 28 times 14 is 392. So when you read this question, the question's basically asking you to find the bearing of O from B. So the lifeboat is at B, so I'm going to draw a north line here. And to find a bearing, you start from the north line and you keep going clockwise. So we're going to look for this angle here. Now, this angle, which is given to us in the question, and this angle here, which I'm just going to call x, are going to be equal. So x is going to equal 135 degrees. And the reason for that is we've basically got, and I'm just going to draw or extend the north line down, because we've basically got we have a set of parallel lines here, and we have a set of z angles, which we know is alternate angles. So the reason for that is it's alternate angles. And always show the reasons to the examiner. Okay, and so to find out what the bearing is, so the bearing of O from B, it's just going to be 360 take away 135, and the reason for that is angles on a point. We've run out of space. Okay, so we're going to do 360 take away 135, which is 225, and so our answer is 225. So we know that James knows that he has a square, so we can actually get rid of all of this bit. It's not relevant at all to the question. And the question asks, what is the probability that the square is blue? Well, there are 3 blue squares, so it will be 3 over, and how many are there in total? Well, it says the total is 17. So the answer is 3 over 17. So let's look through this question to see what information we're given and what information we're looking for. So we're given the acceleration is 13 meters per second squared. We're also given the distance is 19. And we're also given the end velocity, which is v, is 34. And we're looking for the initial velocity. So which of these formulae include A, S, V, and U? That's got a T in it, that's got a T in it, so it's going to be this one here. So let's write that out. V squared equals U squared plus 2AS. So that would be 34 squared equals U squared, because that's what the one we're looking for, plus 2 times 13 times 19. Okay, so let's just work these parts out. And so we've got 2 times 13 times 19, which is what, 494. And it turns into a solving part, so we're just going to solve this. So the first thing I'm going to do is subtract 494 from both sides. And so we're left with 662 equals U squared. Then we're just going to square root both sides. And so square root of that is going to be 25.729 blah blah blah. And it says it wants it to 2 decimal places, so it's going to be 25.73. So in this question we're told that the centre of enlargement is at 6, 4. So let's just put across there. And what I'm going to do is just draw ray lines from the centre of enlargement, and we're just going to go through each of the corners of our shape A. And we're going to just check whether it goes through the corner of shape B, which it does on this one. Let's just keep going. Yeah, it does on this one. But it does not on this one. So it says find the coordinate of the vertex of shape B that is not correct. So the coordinate is this one here, and so that would be -4, 1. So the first thing we need to do is work out the mean for the data in the table. So to start off doing that, we're going to work out the midpoint of each group. So we've got 80 to 85, and to find the midpoint, you add the 80 and the 85 together, then you divide by 2. So this will be 82.5, then 87.5, then 92.5, then 97.5, and then finally 100 plus 105 divided by 2 is 102.5. Next we need to find the FT, which is just the frequency times the duration of calls. Now, in this first group, we're not timesing it by 80 to 85 or anything like that. We're timesing it by the midpoint. So our midpoint effectively becomes the T. So we're going to do 15 times that, which will be 1237.5. And we're just going to keep going and multiplying each of these together. And then finally 2050. Right, next we need to add up the frequencies and add up the FTs. So we're going to have the sum of the frequencies. So I'm just adding all this column up, and that will be 80. And we have sum of the FT. And so we're going to just add this column up here. And so that would be 7,450. So what this column represents is all the numbers added up together. This column represents how many numbers we have. So to find the mean, it's all of the numbers added together, which will be 7,450, over the amount of numbers we have, which is 80. So when you do that, we get 93.125. Now this question is about the improvement that we've made, or that the manager has made, the call centre's made. So we're looking at subtracting the 93.125 away from the last week, which was 105. So we're looking for improvement. And we're going to do 105, take away the 93.125. And that's going to be 11.875. Now it does ask for 2 decimal places, so that will be 11.88. So the first thing we're going to do is work out the area of the trapezium. And the formula for that is half brackets a plus b times h. Now a and b have to be the parallel sides. So here we've got the 2 parallel sides here. Just pick a different colour, here and here. So that is a and b. And then the h is the perpendicular distance between them. So perpendicular means it hits it at right angles. So that's what we've got here. So the area would be half times a, which is 28, plus b, which is 14, times the height, which is 14. And so that would be 294. Next we'll do the circle. Now it doesn't look like we've got anything for the circle, but actually the height here is actually the height of the circle as well. So the height of the circle is the same as the diameter. So the diameter of the circle is 14. Therefore the radius would be half of that, which is 7. And the area of a circle is pi times the radius squared. So it would be pi times 7 squared, which will be 153.938 blah blah blah. Now keep that in my calculator, because next thing we'll do is the shaded area part, and it says we want to work out the area of the shaded region. So the area will be the total area, which will be the trapezium, take away the area that we don't want, which is this bit here, which will be the circle. So So the trapezium's 294, the circle's 153.93, blah blah blah. And when you do that, you get 140.061, blah blah blah. It says it wants it to 2 decimal places, so it would be 140.06. So first thing to realise is that the formula for a volume of a cylinder is pi r squared h. So what we need to do first of all is work out the volume of the water butt that James currently has. So we're going to do the volume equals pi times the radius, which is 89 squared, times the height, which is 189. And when we do that, we get 1497069 lots of pi. And I'll keep this in terms of pi just for simplicity. Now, what we want is we want the volume to stay the same. So we're going to keep that as the volume, 1497069 pi. But we want the radius to change. So instead of the radius being 89, we want the radius to be 103. So times 103 squared. And we're trying to work out what the height is. Okay, so first thing we can do actually is just cross off the pi's from both sides. We don't really need them at all. And then we can get our solving things in, our solving lines, and we can divide both sides by the 103 squared. And on the left hand side we get 141.113 blah blah blah, and on the right hand side we get h. So the height will be 141.113. It says it wants it to 2 decimal places, so that will be 141.11. So I'm going to start off just with a quick sketch, and we know that the bearing of B from A is 85 degrees. So we're going to have A here and B here. And let's just draw a line between them. And let's do both our north lines. And so we know that this angle here is 85 because it's the angle on the bearing of B from A, so it's 85 degrees. So now it says work out the bearing of A from B. So the first thing we can do is actually just draw a line going down here. And we know that this angle here will also be 85 degrees because of alternate angles. It's always best to write that down somewhere, so we can just put in brackets here alternate angles. And we know that this angle here is going to be 180 degrees, so it's a straight line. And I'm not a fan of doing the reasons on the diagram, so perhaps I should have labelled this an X and this a Y and written X equals 85 and Y equals 180 somewhere else. And so to work out what the bearing is, I just need to do 180 plus 85. So 180 plus 85 is going to be 265 degrees. The first thing we need to do is work out the area of the floor. And you'll notice that this is a trapezium. So with a trapezium, the formula is half A plus B times H. And A and B are the parallel sides. So these ones are the parallel sides. And the height is the one connecting the two bases, the two parallel sides. So we're going to start off by writing down the formula. So it'd be half A plus B H. So half times 2.8 plus 1.2 times 11. And when we do that, we get 22. So the area of the floor is 22 meters squared. And it says here that the tiles are soldering packs which cover 3 meters squared. So if each pack covers 3 meters squared, we're going to do 22 divided by 3, which will be 7.33 packs that we need. Now obviously you can't get 0.3 of a pack or 0.33 of a pack, so we're going to have to get 8 packs and just have some left over. So we'll need 8 packs in total. Okay, next thing we look at is the fact that the Jenny has a 25% discount. So we need to find out what 25% discount would do to the £18.60 for the tiles, or for the pack of tiles. And so what we're going to do is we're going to get the £18.60 and we're going to times it by 0.75. So we're just going to find 3/4 of it because she has a 25% discount, and that would be 1,395. So that's the tiles are going to cost £13.95. Now I've done this in pence and I've kind of muddled it together here, so really let's just go back because I've kind of done this in pence. So that would be 1,860 times 0.75, and so each pack will cost 1,395, and the reason we're doing this in pence is the answer needs to be given in pence, so I might as well just make that conversion now. And so it's going to be 8 lots of the 1,395 pence packs, which will cost in total 11,160 pence, or £111.60. But Jenny has £100 to spend, and we're asked how much extra does she need. So we're going to do the 11,160, take away the 10,000 pence that she has, which will give us 1,160 pence. So she needs to find £11.60 or 1,160 pence from somewhere. So we're looking for angle DEC, which is this one here, but we can't go directly there. We've got to kind of work our way towards it. And the first thing I'm going to look at is the set of parallel lines here. And we've got a line going through these parallel lines, which is this line. If I try and do it without removing it, this line here. And so therefore this angle here and this angle are going to be corresponding. So this is going to be 69 degrees. So I need to write that down properly. So angle CDE equals 69 degrees because of corresponding angles. Okay. So if I know that the CDE is 69, I also will know that this angle here is 69 because they're the bottom two angles in a triangle. Now, when I say that, I mean when an isosceles triangle is the right way up, the bottom two angles are equal. So they're the bottom two angles in an isosceles, although the isosceles is on its side here. And we need to write that down, so it would be angle DCE equals 69 degrees. And this time it's because it's an isosceles triangle. And finally, we can work out what CED is by taking those away from 180. So angle CED, or actually I should keep it as it says in the question, DEC, is equal to 180, take away the 69 plus 69. And the reason for that is angles in a triangle equal 180 degrees. And when you do that, you get the answer of 42 degrees. So the answer is 42 degrees. So the first thing I notice is the second equation isn't really in the normal format for doing simultaneous equations. So I'm just going to rearrange it so that we have it where we want it to be. And I'm just going to put my lines in so I can rearrange. So the first thing I want is the x's and y's on the same side. In fact, actually all I need to do is take away 4y from both sides, and we get 5x minus 4y equals minus 7. Okay, so what we do now is we put both our equations down so we can solve these simultaneously. So 5x minus 4y equals minus 7. And you notice the coefficient of the y is already the same, so we don't need to multiply anything. But the signs are different, and the d in different is the d in add. So we're going to add going downwards. So we're going to add everything. So we're doing 3x plus 5x, which is 8x. 4y plus minus 4y is nothing, which is good, because we want to get rid of that. And 47 take away 7 is 40. Alright, let's put our solving lines in. And we're going to divide by 8 both sides. So we get x equals 5. And we're going to substitute that value into one of the equations. I'm going to pick this top one. So instead of 3x, we're doing 3 times 5 plus 4y equals 47. Get my solving lines in. So that will be 15 plus 4y equals 47. And then we're going to take away the 15 both sides. And so it's 4y equals 47 take away 15, which is 32. Divide by 4 both sides, and we get y equals 8. Now we can check that using this equation here. So 5 times 5 is 25. Take away 4 times 8, which is 32, is minus 7. So we know we've got it right. With these questions, it's normally easier to view these as two separate triangles. So we've got a small triangle here with 19 and 47. And what I'm going to do is I'm just going to move this out. And we've got a bigger triangle here. And we've got, well, we've got a bit of, we don't really know what any of the sides are just yet, but we can work them out. Okay, now we know that both of these triangles are similar, and the reason is they share an angle and the lengths at the bottom are parallel, so they will be similar, which means one's an enlargement of the other. And we are given some information in the question that the ratio of BC to DE is 1 to 6. So BC is this length here, and DE is this length here. So we're actually given the scale factor because we know that 1 times 6 is 6. So we know the scale factor is 6, and it's asking us to find length AD. And so the corresponding length to AD, which is this one here. So all we need to do is get that 47, times it by the scale factor, so times it by 6 to get to our value. So it's 282. We don't have to for this question, but it might be helpful to draw a Venn diagram for this. And we've got green and brown leaves. So we'll have green on the left and brown on the right. So green and brown. And we're told that there are 19 green and 15 brown and 6 that were not green and brown. So the only number we can put in is the 6 on the outside of the Venn diagram. We're told that 19 are green, but we don't know which, either they're in here or a bit of both. So what we can do is we can label the center X, and we can say that there are 19 take away X just green, because they could have been both green and brown. And for the brown we can do the same, so it'd be 15 minus X. And For the next step, we know that all of them together add up to 32, because it says in the question. So we're going to add all of these, the 19 minus x, the 15 minus x, and the 6 together, and we know that equals 32. And let's get our solving lines in. So we've got minus x and minus x, that's be a minus x. And we've got 19 plus 15 plus 6, which will be 40, equals 32. We're going to take away the 40 both sides. And we can just times by minus 1 both sides to make them both positive. So now we know x is 8, we can start filling in the Venn diagram. So it's 19 take away 8, which will be 11. X is 8, so we know that that's 8. And 15 take away 8, which is 7. So find the amount that were green and brown. We know it's going to be 8. So we need to first of all work out what the length of the side of the square is. And to do that, what we do is we get the 44v to the power 4 w to the power 5, and we just divide it by 4. And to do that, all we need to do is just divide the coefficient by 4. So it'd be 11v to the power 4 w to the power 5. Some people will try and do something with the v to the power 4 w to the power 5, but if you think about it, if I just draw out my square, if it's 11v to the power 4 w to the power 5 all the way around, when you add, you don't add the v to the power 4 w to the power 5, it's just going to be 11 lots, another 11 lot, another lot of 11, and another lot of 11. So it's 44 v to the power 4 w to the power 5 in total. And to work out what the area is, we obviously are going to square that. So we're going to do 11 v to the power 4 w to the power 5, and we're going to just times it by itself, which is what squaring means. Okay, so we're going to times the 11s together, so that's going to be 121. Going to times the v to the power 4s together, and remember with indices, if you times two powers of the same base, and they're both v, then we just add the powers together, so that'd be 8. And we're going to add the w to the power 5s together, so that makes 10. So it's 121 v to the power of 8, w to the power of 10. First thing I'm going to do is add these column vectors. So we're going to add the tops first, and then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be minus 4, and 11 take away 14 is minus 3. Then I'm going to pick a point on my shape, and the the top one tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a minus 3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. I'm going to do just a quick multiplication grid. And what I'm going to do is I'm going to put the 2x plus 3 at the top, so 2x and then plus 3, and then 3x minus 11 down the side. Multiply them out, 3 times 2 is 6, so that'd be 6x squared, 3 times 3 is 9, so that'd be 9x. Minus 11 times positive 2 will be minus 22x, and then minus 11 times positive 3 will be minus 33. Get them all together, so we've got 6x squared plus 9x, because that is a positive, minus 22x minus 33, And we can see here that the plus 9x and the minus 22x are like terms. So we can add them together to make minus 13x. And that's our answer. So our answer is 6x squared minus 13x minus 33. It doesn't look like it, but we actually have a quadratic here. And the reason it doesn't look like it is because we don't have an x term. But as long as we have an x squared term and a number term, we definitely have a quadratic. And notice something about this second number. It's a negative version of a square number, and that will always be the case because this question is using something called difference of two squareds. And it's very, very simple to work out. What you do is you put down two sets of brackets and you square root the first term. Well, that's just going to be x. And you put the positive and negative versions of the square root. So we're going to square root 121, which is 11. So we're going to put plus 11 and minus 11, and that's it. Now, when we expand that, and we'll just go quickly expand that now to have a look, it's going to be x squared plus 11x minus 11x minus 121. And notice that the two x terms cancel each other out, which is why we don't have the x terms. First thing we need to do is find out what 10% of the 109 is. So we're just going to multiply by 0.1. And that gives us 10.9. So what we're going to do is we're going to add and subtract this from 109. So we're going to do 109 take away 10.9, which gives us 98.1. And then we're going to do 109 plus 10.9, which will give us 119.9. So our error interval is between 98.1 and it says to use t, and 119.9. So to draw a box plot, we need 5 points. We need the lowest point, lower quartile, median, upper quartile, and highest point. Now we already have the lowest and highest points, so we can put those onto our box plot now. So the lowest point is at 0 and the highest point is at 30, as we can see on the cumulative frequency graph. So we need to now find out where the median is. Now the graph goes up to 20, the actual line goes up to 20, so the median we're going to find at 10. We're just going to draw a line across and down, and that looks like it is 17. So our median will be at 17. So we're just going to draw a line at 17. Get it just perfect, there we are. Okay, next thing, we're going to look for the lower quartile. So if the median, we drew a line across at 10, the lower quartile would do it at 5, which will be here. So that's at 12. So we're just going to draw a line up from 12. Fill in this box, and we can actually fill it in with the lowest point. And lastly, we need our upper quartile. And we do that by adding the 5 and the 10 together to make 15. So we'll draw a line across from 15 and down. And that's 23. So a line up from 23. Try and get this as nicely as I can. I need to move that line a little bit. Oops. There we go. And let's fill in the last bit, join it up with the highest point. And there's our box plot. So here we're going to solve a quadratic using a calculator, using the quadratic formula. And the reason we know that is it asks us to do it to 2 decimal places, so chances are it's not going to factorise. So we're going to find out what a, b and c are. And a is the number before the x squared, the coefficient of the x squared, which would be 5. B is the coefficient of the x, which would be minus 6, and then c is the number left over at the end. So we're going to write the quadratic formula, but with our values in it. So we have minus b. Now I always put the values I substitute in brackets, and the reason is that if they're negative, you can make mistakes, especially here when it's b squared if you don't put it into brackets, it won't give you the right answer because it will square the 6 and then put a minus before it. Minus 4 times A times C. And if you always put them in brackets, you don't even have to think about it. It'll always be right. And then over 2 times A. Okay, we're going to put that into our calculator with a plus there first. And it gives us 2.320 blah blah blah. And we're going to do the same thing again, but we're going to use our calculator to go back to the plus there, and we're going to change it to a minus, and then we're going to press equals. And that gives us minus 1.120 blah blah blah. So it's 2 decimal places, it's going to be 2.32 and minus 1.12. So we're told that y is inversely proportional to the cube root of x. And to get rid of this proportionality sign here, we just convert it to an equals and times the right hand side by k, which represents a constant. And we now need to figure out what that constant is. So we're going to feed in the value of y and x that's given to us in the question. So we've got 10 equals k over cube root of 343. Okay, next thing we're going to do is we're going to solve that. So put our lines in. Now the cube root of 343 is 7. So we can actually just, it's a lot easier. And we're just going to times both sides by 7. So k equals 70, and we're just going to rewrite this, but instead of k, we're just going to write 70. So y equals 70 over the cube root of x. We're going to start by working out what outcomes will give us 2 different types of drink. So we could have OA or AO. We could have AW or WA, and we could have OW or WO. Now what we notice really when we do this is that OA gives us the same probability as AO, same with AW and WA, same with OW and WO. So we're going to just ignore the right hand side ones, and we're just going to focus on the left hand side ones. To work out the probability of O and then A, so orange juice then apple juice, we work out the fact that it's 6 over, the probability of picking orange juice first of all is 6 over 27. And then if we picked an orange juice, the probability of picking an apple juice would be 9 over 26. And so that would be 54 over 702. Apple juice then water would be 9 over 27 and then 12 over 26, and so that would be 108 over 702. And then orange juice then water will be 6 over 27 and 12 over 26, and that would be 72 over 702. Now we're looking at the probability of this or this or this, and the word or means add. So the probability of OA or, I should put that in brackets, probability of OA or AW or OW is these added together. And when you add them together, you get 234 over 702. Now, I said we would deal with the reverse situations now. I'm going to deal with that now. And as I said, OA is going to be equal to AO, AW is equal to WA, and OW is equal to WO. So all we need to do to find the probability that the drinks are different is get the 234 over 702 and just double it. And we can do that by just doubling the numerator. So 468 over 702. That cancels down to 2/3. So there is a 2/3 chance that the drinks will be different. As always with this type of question, we want to get rid of the fractions or brackets if we have any. Here we've got some fractions, so we're going to start by getting rid of them. I'm going to start by copying down the question, and I'm going to give plenty of space because these kind of questions do get out of control quite quickly. And so we've got 2 over x plus 10 over x plus 10, and then we've got equals 7. So I'm just going to scroll down and just give us lots and lots of space. Put my tram lines in for the equals. Okay, first thing I'm going to do is I'm going to get rid of the fraction on the left hand side. I'm going to do that by timesing everything by x. And don't forget, it's not just both sides, you've got to times all the terms. So we're going to times the first fraction by x, which will just give us 2. Times the second fraction by x. Well, when you times a fraction by something, you times the numerator. So it would be 10x over, and it would be x plus 10. Denominator stays the same. And here it just becomes 7x. Next, we're going to get rid of the second fraction's denominator. So we're going to times by brackets x plus 10, both sides. Okay, so 2 times x plus 10 is just going to be 2 brackets x plus 10, but I can actually just expand it now. 2x plus 20. Then it's going to be 10x, because the times x plus 10 just gets rid of the denominator. And then here, let's try and expand this as we go. And so we do 7x times x, which is 7x squared, and 7x times 10, which is just 70x. Next step we're going to do is just move everything on the same side. Now, I normally keep the x squareds positive if I can. So wherever the x squared is, I move everything else to that side. So we're going to collect the 2x and the 10x, and we're going to take away 12x from both sides. So we've still got that 20 on the left hand side, and here we have 7x squared, where is it going to be, plus 58x. I'm going to take away that 20 from both sides, because with quadratics, to solve them, we always need it to equal 0. Right, now, little hint in the question, it says, write your answer to 2 decimal places. That normally means we're going to be using the quadratic formula, and looking at this question, it doesn't look like we can factorise it. So, quadratic formula, we need to know what a, b and c is, or are. A is the coefficient of the x squared, which is 7. B is the coefficient of the x, which is 58. And c is the number on its own, which is minus 20. The quadratic formula is x equals minus b plus minus the square root of b squared minus 4ac, and all of that over 2a. So, putting in the numbers, it would be minus brackets 58, and I always put brackets around these, because if they are negative, it makes it a lot easier and a lot more reliable. Minus 4 times the 7 times the minus 20, and all of that is going to be above 2 times the 7. Okay, so we type that into our calculator with a plus, first of all. So you get your calculator out, type all that out, and you should get 0.331, etc. And then on your calculator, you go back to that plus and change it to a minus, and you should get minus 8.62. Oh, hang on, that's not quite right. 8.617, blah, blah, blah. Rounded too early there. And then when you round those, you should get 0.33 to 2 decimal places, and the other one will be minus 8.62 to 2 decimal places. And looking at that, So the angle we're looking for, if I just draw a line here, the angle is HEG, which is this one here. So I'm just going to call this X. And what I'm going to do is I'm actually just going to draw out the triangle in a 2D way. And I'm just going to use this one. There we go. So we've got E down here, H and G. We're looking for this angle here, which is X. And we're given the fact that this is 14 and this is 12. And so what we're going to do is obviously use trigonometry because we've got right angle triangle here. So the first step is to label the sides. So hypotenuse is opposite the right angle, opposite is opposite the marked angle, and adjacent is between the right angle and the marked angle. And next I'm going to put my triangles in, and those are going to be SO, CA, TOA. Well, if you look, the H does not have a number or letter next to it, so we cross that out, and so we're looking for the one without the H, so that's going to be TOA. TOA is short for tan the angle equals the opposite over adjacent. The angle is what we're looking for, so I'm just going to call that X. The opposite is 12 and the adjacent is 14. Get my solving lines in because we're going to do the inverse tan both sides. And so we've got X equals the inverse tan of 12 over 14, which is 40.601 blah blah blah. And two decimal places, that will be 40.60. Here we've got a cubic graph and we're asked to find out what the equation would be if it was in this form here. So first of all, notice that we've got a negative cubic. A positive cubic looks like this. So we've got a negative cubic, and there is a minus sign there that just deals with that. So we don't need to worry about the fact it's a negative cubic because that minus sign just means it's negative, fine. Next thing we want to do is find the roots. So the roots are where the line crosses or touches the x-axis. So here we can see it touches it at 6, so when x equals 6. And here, now this is an interesting one, it actually touches it twice. It touches it at -7 the first time going down, and then it touches it at -7 going up. So there's technically two roots there, sort of one root, but it counts twice because it's going down on one route and then up on the other route. So with these, what we need to do is we need to make sure that at x equals 6 and x equals -7, that this equation, the whole thing equals 0. So if we imagine A, what does A have to be to make this whole thing equal 0 when we look at this, the fact that a root is at 6? Well, if we put A at -6, we get x -6 in that bracket there. And if we put in the value of 6, then it's 6 minus 6, which is 0, and so the whole thing is 0, because anything times 0 is 0. So if A is -6, let's have a look at B. So what does B have to be? Well, if that's -7, if we put B as +7, then when we substitute in this -7 here into the x, we get -7 plus 7, which is 0. So if B is -7, then the whole, +7, then the whole thing will be 0 at x equals -7. And for the C, we're looking at that last root. Again, it'll be the same, won't it? It'll be x plus 7. Now, you might ask the question, how do you know which is A, which is B, which is C? Actually, it doesn't matter. We could put A at -6 and A at 7 and B at -6 and C at 7. As long as one of these is -6, one and two of these are 7, you'll always get the right answer. So I'm going to first of all just draw out the diagram a bit bigger, just so we've got a bit more space. And we're looking at going from B to M. and M is about here. Now the first thing to notice with M, I'm just going to quickly label the other parts on, is that the ratio of A to M is 1 and M to C is 4. So the ratio is 1 to 4 between the two. And what is really helpful sometimes is just to label in the kind of section. So if A to M is one section, we've got 4 of the sections from M to C. So just put like notches there to show the 4 sections. And we can see straight away that A to M is 1/5 of that distance. That's why it's a nice, easy way to show that A to M is 1/5 of that distance. Let's just put a nicer 5, there we go. And so we're looking at going from B to M, but we can't go directly from B to M. We've got to go from B to A to M, and that's going to be the direction of travel. Now, we don't know the name of the road between A and M. In fact, we don't know the name of the road between A and C. We've got to first of all work out what that's called. So what we're going to do is we're going to go from A to C by going down here and then up here. So we can find out A to C is going to be going backwards down A, then up B. Now A to M is going to be 1/5 of A to C. Now if A to C is minus A plus B, that means A to M is going to be minus 1/5 A plus 1/5 B. Now we're asked for the vector B to M, and we know that that's going to be B to A plus A to M. We know B to A because it's labelled, it's just A. And we know A to M because we've worked it out down here. And it should be minus, let's get rid of that, because we know it's going to be minus 1/5 A plus 1/5 B. And so A minus 1/5 A is going to be 4/5 A. And then we've got the 1/5 B. So it's going to be 4/5 A plus 1/5 B. So we're going to start by completing the square, which it's asked us to do. And so to complete the square, what we do is we put a set of brackets down and we put x minus half of the coefficient of the x, so minus 5, and square it. And if you were to expand that, you get x squared, brilliant, minus 10x, fantastic, plus 25, so we need to remove that 25. And then we've got the minus 11 there, just that was on the end there. When you tidy that up, you get minus 36. Okay, now I'm going to draw the graph of y equals x squared. Oh, I'm going to sketch it. It will look something like that. Probably a bit of a curvier bottom on that. Let's try again. So it's going to curve at the bottom and go up like that. Okay, and the bottom of it, this part here, is at the coordinate 0, 0. Okay, now we remember, hopefully, from graphic transformations, is if you have got a minus 5 on the inside of a function, and if we imagine that this is our f of x, then this would be our f of brackets x minus 5, because it's got the minus 5 there. We move the graph to the right 5. Remember, it goes the opposite way. So if it's a minus 5, it goes to the right. If it's a plus 5, it would go to the left. We also know that if you have a minus 36 on the outside, which we do here, it moves it down 36. So it's going to go down 36. So our new minimum point won't be at 0, 0. It will move to the right 5. So the x coordinate will be 5. And it'll be moved down 36, so it'll be minus 36. A simple trick when you're finding the inverse of a function is to replace or to switch the y and the x. Now we don't actually have a y in here, but we can just put one in, it's not a problem. So we can just rewrite this function as y equals x over 10 minus 11. And we're just going to switch around the y and the x. So x equals y over 10 minus 11. Now, the objective now is to get the y on its own, to make y the subject. So we're going to first of all add the 11 both sides. And I've made an amateur move here. I've not left myself enough room, so let's just scoot that across. Okay, so add the 11, so it would be x plus 11 equals y over 10. Next thing we're going to do is multiply by the 10 to get y on its own. So it would be 10 brackets x plus 11 equals y. Expand those would be 10x plus 110 equals y. Now this doesn't equal y. We are looking for the inverse function with this notation here. So we just replace the y with this notation and we get 10x plus 110. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.